Let's take a look at two additional examples to make sure we understand how patterns are defined and assessed in the cross-ordering's pattern analysis procedure. So previously, we examined the relationship between these self and other extroverted ratings. Let's go ahead and move those out. And now let's look at the relationship or association between gender and the self-neuroticism assessment. So let's go to the defined pattern window and notice gender's down the side, neuroticism's across the top. So suppose that we have an integrated model or theory that predicts the males will by and large choose the non-neuroticism option or the neither option, and the females will choose the neuroticism option or the both option. So even though this might look a little bit different than anything we've seen before with traditional statistics like a Pearson's correlation or a chi-square type of analysis, this is nonetheless the expected pattern. So these cells are where we should see most of the observations. So let's go ahead and take a look at how we did. We can see 49, 22, 24, and 1 looks pretty good. We have 9, 17, and 18, and 2 where they shouldn't be, but it looks like we're beating 50% here. We can go ahead and let the software tally this up. So we'll select OK and OK to run it. And there we get the percent correct classifications index. So it's 96 out of 142. That's 67.61%. So even though the pattern may look a little bit odd here, if it matches our theory, our expectation, then that's what we do. We set it up like that and then just tally how many individuals match the expected pattern. Now let's take a look at some data that are quite different. Let's look at these height data. So here we have 206 individuals and their heights were measured in centimeters by two independent lab researchers. Now we would expect these to be highly correlated or associated. So let's look at the analyses, pattern analysis, cross-orderings procedure. I'll move the two heights over and we'll take a look at the pattern. Now this thing goes off the page here because it's quite large. Notice how the data are scaled. So we have 134 to 134.9 for height 2. We have the same scaling for height 1, 134, 134.9, and we get 135 to 135.9 and so forth. So we might expect a unit-to-unit matching here. So if one individual is measured here, the other individual should measure that same person here, and so forth. So we could go through and set up the pattern just like that. Now what we can also do is give it some width. Give it like a confidence interval, if you will. We could make it a little less precise. So I can set the imprecision to 1, and now notice how it gives it a little bit more breathing room here. So you can be within plus or minus 1 units of the expected observation or unit of observation. I'm going to right click and delete that out. I also want to show you, if I just click here, you'll notice it creates like a little cross. If you indicate the diagonal or select the diagonal, then what it will do is fill in the diagonal elements as well if you want to set up your pattern in this way. So I'm going to right click here and right click and delete those. Now more importantly for our purposes for this example, so I'm going to minimize this or shrink it rather until it fits on the page. And now what we want to do is set up that one-to-one unit matching. Now it looks like a negative slope, but it's not a negative slope. This is not a regression analysis. It's a unit-to-unit matching. And the way we have the data just sort of set up here, it goes from left to right here and from top to bottom. So I can use this arrow here, this descending pattern. It's 1 unit origin, it starts there, and it's a 1 unit change. So it's a 1-to-1, and there you have it. Now here I've got the imprecision set to 1. Let's set that back to 0. And turn off the diagonal. Let's erase this. And then there we go. So there's the unit-to-unit matching. Now where are the observations? It's actually not too far off. They do fall almost on that perfect unit-to-unit matching. Again, I can widen this out, give it a little width in that expected pattern, and reset it. And now we can see almost everyone falls within that plus or minus 2 unit-to-unit matching. And I can see there are 1, 2, 3, 4 individuals in particular who did not match. So let's go ahead and select OK and run the analysis. And there we have it. So 202 out of 206. So that gives us the percent correct classification of 98.06. Quite a high percent correct classification index. So if we give it a little bit of breathing room there, a little bit of bandwidth in our expected pattern, it still looks like a one-to-one kind of matching between the two height measures. So this is clearly not a standard regression analysis, but you can nonetheless test the association, even the linear or unit-to-unit association between pairs of orderings. And this makes this pattern analysis procedure really quite flexible.